Hi, welcome to your lesson on creating quadratic models. Sometimes we only know a few points along a curve, but we know it's going to be quadratic. It's going to look like a parabola. In this lesson, our goal is to figure out how can we make a perfect equation to model some points that look like they follow a parabolic shape. Alright, but before jumping into that, let's do a warm-up. And the warm-up will be all about two forms of quadratic functions. We've learned about these three forms: standard form, vertex form, and intercept form. And we know that when we go from a standard form to intercept form, we can follow the process of factoring. Let's practice with that skill first. So to recap, when we want to factor, if we have a quadratic trinomial where the a value is 1, we can simply think about two numbers that multiply to 48 and also add up to 14. So that's our a, b, c value. Here we put a times c, which is the 48. So again, a times c, what two numbers multiply to 48 but add up to 14? So what are those two numbers? Well, 8 and 6 work. So 8 times 6 is 48 and 8 plus 6 is 14. Therefore, this will factor into x plus 8 times x plus 6. If you multiply that back out, you'll notice you get back to here. However, we're going to take this a step further by saying solving it. When we say solve a quadratic, we mean make the y value 0. So we set y equals 0 and then we solve. And to solve this, we know that one of these two factors must be 0. So we say x plus 8 equals 0 or x plus 6 equals 0, because one of these must be 0 if these will multiply to make 0 here. So that one gives us an answer of -8. This one gives us an answer of -6. So that is solving by factoring. And by doing factoring, we change from standard form to intercept form. These two values will be our x-intercepts on the graph. If you graph that parabola, you'll notice it looks like this. And there are two x-intercepts. They match the 2 points we got. And the reason those are the x-intercepts, again, is because we set y equal to 0. And when we set y equal to 0, we're looking for two x values along that line, y equals 0, which are our x-intercepts. Okay, try that with this one. Check your work. So factored form is like this. We set it equals 0. Solve each of the factors when it's set equals 0, and we get two answers of -2 and -3. Alright, let's talk about factoring when a is not 1. Notice here a is 6. So now we multiply a times c again to get this value. 6 times 12 is 72. 17 is our b value. So again, we're thinking of two numbers that multiply to 72 but add up to 17. Those two numbers are 9 and 8. 9 times 8, 72. 9 plus 8, 17. So now, instead of going right to factored form, we take the middle term and we split it into these two values. So 17 becomes 9 and 8 right here. Now we do what's called grouping. We take the first two terms, group them, second two terms, group them, and then we factor something out of each of those groups. Here we can factor out 3x from that to get this. Here we can factor out 4 from that to get this. Notice now we have a common factor. That common factor can be factored out as well, so the 2x plus 3 has been factored out and we're left with 3x plus 4 here. So there's our factored form. We can of course set that equal to 0 as well in order to find the x-intercepts, and set each factor equal to 0 like this, and solve. This one you'll move the 3 over, divide by 2 to get -3 halves. This one you'll move the 4 over, divide by 3 to get -4 thirds. Those are two x-intercepts for this quadratic. Okay, try with b. Okay, when you solve b, first, if you do the grouping technique, you'll notice the two numbers that multiply to make -8 but add up to -7 are these two numbers. Grouping gives you this, and therefore the factored form is this. Then you solve, 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 you get these two solutions. Please check your work carefully. Next one, try C. Okay, in C, again, we expand it like this. Two numbers that multiply to 9 but add up to 6 are 3 and 3. Then grouping, and then that grouping brings us to this factored form here. Notice we have the same factor here repeated. So you only have to solve once for 0, and you get this answer here. It's important to know with these that this one then, since we see it here like this can be factored into this, because this is like 3x plus 1 times itself. That is called a perfect square, because something times itself, and when those two things are the same, that's a square, right? So this is called a perfect square trinomial. And perfect square trinomials, when you graph them, Notice why we only have one solution. They will always graph like this, where the vertex will sit on the x-axis. Therefore, our x-intercept is the vertex. So that's why there's only one solution, because the vertex is there. Imagine this graph moved down a little bit, then there will be two solutions. This is called a double or repeated root. So this solution here is called a double or repeated root, because even though it's one solution, we still call it a double root because it would happen twice here. Okay, try A. In this one, you might have to move some things around to get 0 on one side. Remember, we need 0 on one side to solve. Okay, check your work for that one here. So here it is when you move everything to one side, and then you expand the middle term, factor, and then continue from there. So factored form looks like this, and then our two solutions are here. Check your work. And now you're ready for B. Maybe you've tried it already. So here's B. We moved everything to one side, and then solved here. Great. Thank you for looking at factoring. It's good to always practice that skill. It's essential skill in quadratics. So now let's move into the heart of our lesson, which is creating quadratic models. Like I said, imagine you have some points and you want to make a perfect model that is a parabola for those points. So if those points seem to follow a trend that looks parabolic, we can make a parabola match the data. And we're going to look at all three forms. So sometimes this form is best, sometimes this one, sometimes this one. All right, your choice. Part of the decision process in these kinds of problems is to look at what you're given and decide which form is the best one to work with. So remember these three forms. Let's begin here with this question. How many points on a quadratic graph do you need to know in order to find the parameters? So if we, again, to create one of these forms, how many points do we need to know? Do we need to know this many points in order to create a quadratic model? Well, let's check. Let's investigate in Desmos. Okay, so I have this ready for us here. Here are 2 points in space. Okay, if somebody said, tell me, is there a line that passes through those? You would say, yeah, there's definitely, I could draw one single line that passes through them. Here's the line. So one line. And if they said, well, is there another possible line that passes through those 2 points? Like, are you sure it's this one line? I think you would say, well, of course, it is only this one line. There's no way to draw another line that passes through both. Imagine you had a line coming more slanted coming through this one, that line would not pass through this one. So there is only one line that passes through those 2 points. But now if we ask, okay, well, I have these 2 points and I know a parabola passes through them. Can you think of a single parabola that passes through those two? Well, I have one here. So here's a parabola that passes through those 2 points. But is this the only parabola? If you made an equation for this parabola, are you sure this is the only one that passes through these 2 points? Well, definitely not, because look, I even have another one here. There's another one I drew that passes through both. And actually, there are infinite parabolas that can pass through these 2 points. Imagine narrower, shorter, taller parabolas that keep passing through these points. There's an infinite number of parabolas. So how do we determine a single parabola if we know 2 points? Well, the point there is we need more than 2 points on a parabola to say with certainty that there's only that one single parabola. So with a line, 2 points are enough. With a parabola, we need at least 3 points to say with certainty there's only one parabola. Let's go back. Okay, so back in here, let's say we have this parabola and somebody said make a model for that. Well, we just learned we need more than 2 points. We can see a few points here with certainty. There's a vertex. Well, that one is not very clear. We can't see that what value that is, but we do see the vertex there. We also see an x-intercept and another one. Those ones are clear. They are very clearly marked on there. And we also see a y-intercept, which is very clear what coordinate it is also. So this is -4, 0, 2, 0, and 0, -12. The vertex is not so clear. But hey, good news, we have 3 points. So let's work with those. We're going to try on our calculator first, and here's how it goes. We're going to do what's called a quadratic regression. Enter those 3 points and then find the equation that best matches. So grab your calculator, and here's how it's done. So let's turn it on. We're going to use stat, because whenever we do regression, we use stat. We're going to enter the data we know. So stat, and the number 1 edit is where you enter data. The 3 points we know are -4, 0, 0, -12, and 2, 0. So please enter those as well. These are our x values, these are our y values. So I have them already pre-entered there. Okay, now what you do is stat, and then go to calc by using the arrow. And then you can see, often we've done linear regression where you have points and you try to find a line of best fit. But now we're trying to find a parabola of best fit. So number 5, quadratic regression. 5, There's our list of x values, there's our list of y values, then you go to calculate, and it'll give you the parabola that best matches that data. And there's our parabola. It's in standard form, ax squared plus bx plus c, a value 1.5, b value 3, c value negative 12. That will create a perfect parabola. So here's that equation, and that will be this perfect parabola, and it's the only parabola that can pass through those 3 points. Alright, but usually we can't use our calculator, so we're going to use a more algebraic approach now. So let's say you had these two parabolas here. Look at the points you're given. Which form would be the best? So going back to the forms, standard, intercept, or vertex. For this one, what would be the best form to use? Well, this one would definitely be intercept form because we can clearly see the two intercepts there. How about this one? Which form would be best to work with looking at the points you're given? Well, in this case, vertex form because we clearly see the vertex there. Alright, let's try some problems. Let's say you have the x-intercepts of a parabola are these numbers, and the parabola passes through this point. What's the equation? Well, we're given the x-intercepts, so we'll begin with intercept form, like this. And now we'll put the things we know into that equation. So we know the two x-intercepts are negative 1 and 5, so that means 1 and negative 5. Remember, there's always the opposite here. So those go in. But we're left saying, hey, I don't know if this parabola works. We don't know the a value. Well, here's how we find the a value. Into that parabola, we put the point we know, 4, negative 10. So 4, negative 10, so x values are replaced with 4, negative 10 replaces the y, and now we can solve for a. So solving that, negative 10 equals, this is 5, this is negative 1, so negative 5a, and then divide by that, and you get a is 2. So we figured out that the single parabola that will pass through all those points given to us is this one here. Okay, there's our x-intercepts, and there's the a value that we found using the other point we know, and that is the only parabola that will pass through those points. Okay, and why would this form not be okay? Like here the a value is 1. Why do we know a has to be 2? Let's take a look on decimals as well. This is important to see. So here I have that equation. So here's a parabola that passes through those two x-intercepts that were given. Here's the other point it said it passes through, but right now a value is something else. So notice it doesn't hit that third point. Look, when I change the a, I have all those infinite parabolas that pass through those two x-intercepts. There's infinite parabolas. But there's only one parabola that hits 4, negative 10 also, and it occurs when a equals 2. See, I made a 2, and now it passes perfectly through that point. So that's why knowing a third point is key. Okay, let's try another one. Here we have a vertex is negative 2, negative 4, and it passes through this point. Notice we're only given 2 points. When we know the vertex, 2 points are enough, actually. So we're going to begin with vertex form, because we were given the vertex. So here's vertex form, and we put the vertex values here. Remember, those tell us the vertex. 2, negative 4. This one's always the opposite of what we see here. Now again, we're looking for a, because there's only one specific a value that will give us the exact parabola that passes through here. So we're going to take that point we know, 228, put it into here again. So y here is replaced with 28, and x is replaced with 2. This allows us to solve for a. So 2 plus 2 squared is 4, so we have 4 squared is 16, and then we can subtract 4 and divide by 16, add 4 and divide by 16. To get a is 2. Coincidentally, it's 2 again. Okay, there's our parabola then. A value of 2, vertex form. Is this the only one that's good for this? Let's take a look again. Here is that parabola. Here is the vertex. Here is the point it passes through. And let's say I change the a. See, when I change the a, the vertex is locked. That's good. We know that vertex is exactly what we need it to be. But again, there's infinite parabolas through that vertex. So we need to move it a little bit more until we get it to hit that point. And then notice that happens exactly when a is 2. So that single parabola now passes through there. Okay, let's continue. Try this one. Okay, and now check your work. Alright, so notice there's our, hopefully you got that one to work out. We started with the x-intercept form again. How about this one? Try this one out. Okay, this time you're given the vertex, so we start with the vertex form, then you put in the point you know, calculate for a, and then you know the single parabola that must pass through those points. Alright, let's try another. And in this one, you're given the vertex, x-intercept, y-intercept. You're given more than you need. Alright, so start with the vertex form, put in the vertex. Then you can put in either 5, 0 or 0, 5 because you have those 2 extra points. I put in 5, 0, solve, and then you get that parabola there. Alright, let's go back to the 2 we started with. Find an equation for a. Okay, that one again, you're using intercept form, so check your work there carefully. And then it's changed into standard form. and then try this one here. In B, we used the vertex form because we were given the vertex, and we got to here. Hopefully, you had lots of success with that. Great work.